From the surface, it's impossible to see what's new about curing concrete. But simple changes in the materials and processes result in increased durability and reduced cracking. It's worth taking a closer look.
Internal curing is really doing the basics of concrete. It's really water curing concrete, but instead of supplying the water from the outside, we're really supplying the water from inside the concrete mix itself. So we hide water inside of the concrete to provide internal curing.
Internal curing of concrete has been the subject of many laboratory and field investigations over the last 20 years. Up to this point, it has been primarily used in bridge deck applications. However, now pavement applications such as continuously reinforced concrete, jointed plain concrete, and pavement repair projects are being examined for potential applications of internally cured concrete. One of the agencies leading the way into this paradigm shift, the Illinois Tollway. Materials Deputy Program Manager Steve Gillen says the results so far are very promising.
Pavement applications, the benefit that we're seeing, or we're hoping to see, is the ability of the internal curing process to modify the cracking patterns in continuously reinforced concrete pavements so that the cracks can be maintained at a tighter width to prolong the life of the pavements or reduce the steel content and make them more economical to build.
Here's how the process works. Manufactured lightweight aggregates such as expanded shale, clay, slate, and slag is used as a substitute for a portion of the normal weight aggregates to provide a source of moisture. Prior to batching, the lightweight aggregate is pre-wetted in a stockpile with a sprinkler or soaker hose. Next, a drain-down period reduces surface moisture and increases uniformity throughout the stockpile. Water is held in the voids of the lightweight aggregate and released into the concrete after the paste has hardened. The mixing and placement of internally cured concrete is identical to conventionally cured concrete. Once the concrete sets, the structure and pour network are established. Any remaining water, curing water, only aids in hydration. During the curing phase, water in the lightweight aggregate leaves the pores of the aggregate and continues the hydration process throughout the concrete structure. The water released later by the lightweight aggregate helps promote more complete hydration. It covers a greater volume of the concrete structure than water that is applied externally. Internal curing is particularly beneficial in concrete with a low water to cementitious material ratio. This is because the water that is absorbed in the lightweight aggregate does not contribute to the classic definition of the water to cementitious material ratio. The water to cementitious material ratio is a descriptor of structure of the matrix and pores that develop in the fluid concrete system, whereas the water provided by the lightweight aggregate during internal curing affects the hardened concrete system. Lightweight aggregate is not the only way to create internally cured concrete.
The other technologies that are available are cellulose fibers. They can actually absorb water and give it back. And then the final one is something called the super absorbent polymer. And the super absorbent polymer is basically like a baby diaper in reverse. The basic idea here is it will absorb some water and hold on to that water until the mix needs it.
To make internally cured concrete with lightweight aggregate, the design of the mixture is key. The mix design is generally identical to that of conventional concrete, with similar air content, water content, and coarse aggregate content. The exception is that a portion of sand is replaced with pre-wetted lightweight sand. Internally cured concrete is attainable for many agencies, mainly due to availability and affordability of lightweight aggregate. Also, fine, lightweight aggregates already appear on the agency-approved materials lists. Some of the fine aggregate is replaced with lightweight aggregate, but the volume proportions remain the same. It's important to note that the water used for pre-wetting the lightweight aggregate is not part of the water in the mix design. There is a wide range of tools that can be used to proportion a specific mixture. A simple spreadsheet is available to convert a conventional to an internally cured mixture design in a simple step. The volume of internal curing water needs to equal the volume of chemical shrinkage water to negate the effects of self-desiccation. Controlling the aggregate moisture is critical for internally cured concrete to attain a consistent mixture. The absorbed and surface moisture in the lightweight aggregate should be carefully measured and controlled to reduce the amount of variability from batch to batch. Two methods are commonly used to determine the aggregate absorption and surface moisture: the paper towel method and the centrifuge method. The paper towel method consists of drying the lightweight aggregate with a paper towel until the towel no longer picks up moisture. In the centrifuge method, a centrifuge spins the aggregate using centrifugal force to bring the aggregate to a saturated surface dry state. This is faster and more reliable than the paper towel method. Internal curing provides increased cement hydration, densified microstructure of the cement paste matrix, improved interfacial transition zone between the aggregate and the paste, reduced permeability, and reduced built-in stress and curing times. These changes can result in many potential benefits, including improved durability, less shrinkage and curling, more efficient use of the cement, reduced joint damage, reduced alkali silica reactivity damage, improved fatigue resistance. Ultimately, internal curing results in fewer and tighter cracks. Increased strength and durability results in a longer service life and lower maintenance costs over the life of the pavement.
So at this point, there's several different groups who've used internal curing. The New York DOT has used internal curing on bridges. The Indiana DOT and some of their local agencies have used it on a series of different bridges. The Illinois Tollway, Texas has used it in a lot of pavements and patches. So to date, there have been over 100 to 150 different bridge decks that have been cast using internal curing, as well as a wide variety of commercial products.
One example of an internally cured concrete pavement is a test section on State Highway 121 near Dallas. This continuously reinforced concrete pavement was constructed in 2006. Initially, the cracks in the pavement had a larger spacing than that of conventionally cured pavements. After several years, the crack spacing was similar to that of conventional sections, but the cracks remained tighter.
But they learned from that project that it developed different crack patterns. Tighter cracks were developed on those pavements. Also, to reduce curling and warping strains on the pavements, it's another reason why we're looking into this as well.
Field experience has shown that in general, internally cured concrete has similar workability and strength with reduced stress development and cracking compared to conventional concrete. But what about the cost?
The internal curing is going to be slightly more expensive than a conventional concrete, so the idea here would be that you're replacing some of the normal sand with a slightly more expensive expanded sand in this case. But the benefits can really be substantial.